If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture again of gate electrical circuits. So today we will be solving from question number 166 onward. Question number 166, 167, 68, 69 and then 70. Okay, then let's try to solve these questions. Okay, in question number 167, what they are asking, the parameter of the circuit shown in figure are Ri is equal to this much, Ro is equal to this much, these values are given, A is this much, Vi is equal to 1 microvolt, and the output voltage, input impedance and the output impedance, this much they are asking. Because your VEI is given 1 micro, this is 1 micro, AVI you know, A is given 10 to the power 6, so here output voltage you can see directly, because no current is flowing, it is open, so simply this voltage will come here, so output voltage will be A into VI, this into this. So it clearly shows that output voltage micro and 10 to the power 6 will go only 1 volt. So obviously option up to option A, B, C, any one of the option. Now for finding input impedance and output impedance you can see here. For finding input and output impedance, the best way is to connect a source here. You connect source and see how much current it is taking. So source divided by current. Like the way we calculate Thevenin's resistance in case of dependent source, we connect a 1 volt source and you see how much current it is taking. So whatever source you connect, no current it will take. So input impedance will be voltage source divided by current. Current is 0. So V by 0 it will be infinite. So obviously you can see the option will be, answer will be option A. By seeing this only you can see. But if you want to calculate your output impedance, so for that input side also we connected one source. I have not shown here, but you can think of, we have connected one source. So in output if we connect another source, so my output will look like this. If I connect a source, suppose of V, I have connected a source. So if you want to see our input impedance and output impedance, what we have to do, we have to connect a source. Okay, if we are connecting source, that means we are killing all other active voltage source. So that was the idea for calculating Thevenin's in case of dependent also. So here also if we connect something, that means we have to kill all other sources. So here other source is nothing but Vi. So you have to kill that Vi. So this voltage will be equal to 0. So this will become 0. So what will be your this voltage? This voltage will become 0 volt. So what will be your I now? So I will be equal to simply V by I will be simply Ro. You can see here in this circuit, because this voltage is gone. So this V is equal to I into Ro. So from output side V by I is equal to, it will be simply Ro. And what is your Ro? To 10 ohm. So your answer is 10 ohm. So you can directly give the answer. Now in question number 168, what they are asking here, 2-port network shown in the figure has port 1 and 2. This 2 port, AB is one port, CD is another port. It has an impedance matrix Z with parameters Z11, Z12, that's the normal conventional parameters. A 1 ohm resistance, it is connected extra now. In series with the network at port 1, the impedance matrix modified because it will be now one 2-port network, another 2-port network, both are connected in cascaded version. This is not seried. In case of cascaded, it ABCD parameters get multiplied. I think you know all this. So the impedance matrix are what will be the modified impedance matrix. So here two-port network is there. One is this one and one is this one, the earlier one. So if I take, this is suppose a V dash. So this voltage, if I take V dash, this is my input voltage, suppose V1. This is my output voltage. Initially, final output input it should be, because this is the final, including these two. And this V dash, because I am considering I1 here, and let me consider I dash here. So in case I have to consider here, what is the convention? If it is a 2-port network, what is the convention? In this direction we take I. So this I dash, this will be minus I dash, which is nothing but, here you can see I1 is I is equal to minus I dash. These are same current but in reverse direction. So here it will be nothing but I1 only. So you can see this one. Okay. Now if I write the equations for this one and this one, suppose the first equation, that is for in case of Z, it will be V into IZ. So if I want to write V1 is equal to, what will be V1? V1 will be I1, this R is 1 ohm. So I1 into 1, this plus this voltage, V dash. Okay, and this is also one equation. From here you can see this is the equation. Here if I write, what will be the V dash? That is Z11 I1 same I1 is coming here, that is minus I dash here, but it is I1 here, so I am directly writing I1, and Z12 I2. So if you put it here, so what will be your final V1? V1 will be equal to, if you take I1 common, if I put V dash here, so this entire thing will come here, then if you take I1 common, what will be your I1 will be equal to 1 plus Z11, and similarly Z12 I2. So now you have got an idea. The first element will be Z11 plus 1, Z11 plus 1, Z1, and second element will be Z12. So either B, C, D, either of these, anyone will be the option. Okay, now for second equation, so for what is the second equation? This side, that is V2. From here if you write V2, because final is V2, this one. So V2 will be equal to what? V2 Z21 I1 plus Z22 I2. So Z21 I1, this is same I1 here, because it is minus I dash actually, but in place of minus I dash I am putting I1. So it remains the original equation only. The final V2 will be also same, because nothing to replace here. I2 is already there. This current I have taken I1 I dash minus I dash. This one I have already replaced I1. So it coming at original expression only. From this I1 and this I2 including these two, it is coming. So there is nothing to change. So this side will be simply Z21 and Z22. That means your option C. So there is no change in the second row. You can see the second row remains same. The V2 equation remains same, because everything in terms of this I1 and I2. Ultimately you have to find this current and this current. This is your I1, this is your I2. So this is my I1, this is my I2. I have substituted this one here. After substituting, it will looking same. So your option is C. So these are linked question 169 and 170. 10 volt connected to port A in linear non-reciprocal network shown below. These are the observation. 1 ohm connected in port B draws a current of 3 ampere. If we connect 1 ohm, it will draw 3 ampere. If you connect 2.5, then it will draw 2 ampere. Another data is given, although this is not required, because with two data only you can find this. The open circuit voltage at, if 8 volt is connected to port A, what is the open circuit voltage at port B? So it is V1 I1 is equal to, if I go for ABCD transmission, then it is V2 I2. This was the sending and receiving end concept. So this I2 was minus I2, this you have to think, but when it is minus, if I consider this is the direction of I2, but if I consider this is the direction of I2, suppose I have considered this is the direction of I2, so then no need to give minus. This is I1, this is I2. But if you consider the original two-port network convention, that is I2, then you have to give minus, because transmission parameter is mainly sending and receiving end. So receiving end we consider this is my V2, this is my V1. So if you see the first case, your V1 is, these conditions are given there. If I write the first one, V1 is 10 volt, this is the connected 10 volt, A into V2. V2 is the, what is the secondary voltage, because if you connect, if you draw the first, from the first given data, 1 ohm, they connect 1 ohm and it draws a 3 ampere. So 1 ohm 3 ampere, so what will be the voltage? 3 volt, plus B into I2. What is the current it is drawing? 1 ampere. So this is first equation. Similarly second equation, same 10 volt they give, but here A into, what is the voltage? If you connect 2.5 now, it is drawing 2 ampere. So if you connect 2.5 ohm, it is drawing 2 ampere. So what will be the voltage? 5 volt, plus B into, what is the current it is drawing? 2 ampere. Now if you solve these two equation, again you can easily solve it. You will find A is equal to B is equal to 10 by 9, 20 by 9. Now once you know this one, now you can calculate anything. Now if you connect 8 volt in port A, what will be the, now 8 volt in port A, that is sending end, 10.9, what will be the receiving end, that you don't know, plus B is 20 by 9, the open circuit voltage, so receiving end current is 0. So it will, you are asked to find this one. So what will be the answer? This one, 8 into 9 by 10, which is 7.2. So in the answer there is no 7.2, but 7 is there, so you take this one. I think some mistake may be there in 2012. Now in 170, if you go in the same way, now they are connected again 10 volt in port A, so 10, A is your 10 by 9 into V2. What will be the V2? The current drawn by 7 ohm resistance. Now they have connected a 7 ohm resistance. This current they know, don't know. So what will be the voltage? 7 into I plus 20 by 9 into, what is the current? Current they don't know, that is I. Okay, now if you solve it, you will find your I is equal to 1. That is your option C. 10 will get cancelled, 9 and 7 plus 2 is 9. So you will get 1 ampere. If you like the video, then press the like button and please give your valuable comments in the comment section.